Hi, this is Bill Wolf, and today is Monday, May 18th, and have a interview today with a customer. He's a plant engineer in our sales territory, and his name is John. And John, welcome.
Thank you.
So John's going to give us a success story in his plant, and just a little background on the plant. It's a coal-fired power plant, and it delivers electricity to the grid and delivers steam to a host chemical plant. And over time, that chemical plant has shrunken in demand. So as it's shrunken in demand, the original steam PRV, steam control valve, which was designed for certain flow rates, etc., can't handle the turn down for the much lower flow rates. So it caused steam inefficiencies, loss of revenue, loss of money, and major maintenance issues because it was basically beating itself up. So John went to the management and said, "Hey, I think I've got a better solution. I like XYZ for a budget. Can I find a better control valve for this application?" So John went out for bid. He invited us to bid, and we were the successful commercial and technical award. And John went with Easter Controls, our startup service team, and also went with the Masoneilan SteamForm control valve. So, John, this is the first time we've ever done this, a podcast with one another. So, starting out here, John, can you kind of give us, without giving away any trade secrets, why did you choose Masoneilan SteamForm, and why did you choose Easter Controls?
Okay. Well, we went to about I think 5 different bidders to get pricing, and we shared all the information with them. And of course, this is a retrofit of an existing valve, and price is always a factor in these types of things. Lead time was another big issue for us because we had budgeted for this project in 2019. And another key issue for us anyway was that the vendor have the ability to locally support us. In other words, he had techs and engineers in their home office that could easily get to us and be on site. So all those things kind of worked out in Eastern's favor for this particular application.
Thanks, John. Well, we really appreciate the business and thank you. I guess you and I were talking about sharing with the viewers the original demand or the original scope, the original design, and then the current demand of the valve that you got to choose. Could you kind of give us some details on that, John? I think that'd be of real interest to the folks viewing this podcast.
Sure. So hopefully we'll be able to share this.
Yeah, there we go. Yeah.
This first item. So hopefully you're seeing the P and ID of the layout.
I am, John. Yes.
Okay. So how we're set up, it's kind of cut off here, but we have 2 boilers, 1 turbine, and the idea being reliability for the steam host, that we always have a ready supply of steam available for them. And what happens is the 2 steam sources, wide together here, and then they go into the turbine together. And the normal operation would be that out of one of the extractions, they take the process out, and it goes, to the steam host. What we did here is there's a branch line here, and hopefully my cursor is showing you this, and it goes to a pair of what they call emergency process steam letdown valves. And the project was to replace one of these and size it to match the current steam demand from the host, and get it to operate a little more in the middle of its control range. So let's we'll just keep going. Hopefully we're going to flip over to, this is the original data sheet for the valve that we provided to the different suppliers. And you can see, a couple things here. Maximum steam flow here was well over 1 million pounds. Okay, in the for its design, and that was at 1,900 pound design supply pressure. Now, typically, our units are now running at about 1,300 pounds because we modified them a few years back to go to sliding pressure. And the sliding pressure lets us run the boilers at a lower pressure and able to open up the valves on the turbine. Um, so you don't have as big a pressure drop across them. And of course, then you don't have as big a pressure drop across the new valve. And I want to jump over to shot. Here is a picture of the new, what
Got
you
it.
guys call the SteamForm valve. And it's sized to take about 300,000 pounds an hour of steam, which would be the total output of one of the boilers should the turbine trip sometime during operation.
Okay.
Now,
Good
one of
stuff.
the considerations that we had in the purchase of this valve was the retrofit aspect of it.
Mhm.
You know, it's an existing right angle valve. You know, steam supply here on the inlet, steam outlet down here, and the ability to match up with the existing piping without a whole lot of extra installation work. And we not only did the sizing, you know, have to match up. It was a 9-inch inlet and a 24-inch outlet, but we also had to get the materials to match up and make sure that it would fit in that space. And we actually lengthened the one end of the valve to totally eliminate an existing weld, which had cracked. So.
Oh, okay. John, thanks. So now you chose your manufacturer, you did your technical assessment. You now have a control valve that's going to meet a much lower demand. What was the installation like? I know you've shared that with me a little bit. You got some really cool photos. But gosh, I think the viewers would really like to hear a lot about the installation, because you did it in, I think, less than 2 weeks. You had to mount this control valve, the SteamForm control valve, on, like, I think it was the 4th floor of the power plant. And if I remember correctly, it was like over 2,000 pounds. So can you share with us a little bit about how that happened? Because it wasn't like you just bought a control valve. You had to do a lot of other stuff to make this
Right.
thing work.
Yes, you are. Yeah, you are correct. Actually, if you look right here on the drawing, it'll show you, you know, that with the actuator on, it was about 2,500 pounds, and removing the actuator, you know, took off almost 500, a little over 500 pounds, you know, in weight. And we actually had to do that to get the valve into the elevator of all places. So just bear with me one time here. Okay, so hopefully now you're seeing an overhead shot.
I am. Yeah.
Okay,
With the
so what
viewers, they
you're
can see.
you're
Yeah.
looking at, I'm standing on the 4th floor here, and this is actually our operators putting the new letdown valve into service. And so the valve we installed here has the red actuator, and we left the other original valve in there, has the green actuator, and that could always still pass up to the million pounds of steam. Now, what you don't see here, because it's all been taken down, is they had a scaffold up from this deck, mount a monorail on the scaffolding, and cut the old valve out and remove it that way, and then mount the new valve in the reverse of that. And so that was probably one of the more challenging parts of the job here, because there was not a lot of places to rig off of, to get it in there. And you can see it's kind of you're kind of shoehorning it into the facility here. And let me hopefully jump pictures here. Where'd we go?
And you needed to have a pretty good contractor for this job, John. I'll tell you what,
Yeah,
man.
no, yeah,
Kudos to them.
Yeah. Yeah, so we hired one of our code contractors, because you're tying into main steam here, and you need an experienced contractor. And one of the big things here, because of the main steam connection, you have over 1.5 inch thick piece of pipe that you're welding to. It's a chrome moly material on the inlet side and carbon steel on the outlet side. And what you see here is a shot of the contractor welding the main steam side, the 9-inch side. And of course, they had to do preheating on that, continuous preheating. And then they had a post-weld heat treatment to do. after the weld passed X-ray. You see the guy in here is what's called a supplied air hood. Because of the chrome content, you have a problem with welding fumes that are hexavalent chromium, and as a result, you have to take the precaution with the welder who is right there in the proximity with the fumes. They also there's different types of welding techniques that you can use to minimize it, but this was a big part of the installation cost, and and getting a contractor that could handle all that part of it. And then finally, I got one more picture here. Here it is, the finished valve installed. It's been re-insulated. And we have one of our local Eastern Controls techs on site. He's running the valve scope to check out the valve and make sure that everything is calibrated and it's going to work properly. So that's about it on the installation side.
That's cool, John. Thanks for sharing that with us. I think the viewers will really appreciate that. Hey, you mentioned getting the valve to get started up and stuff like that. So now that you've been running for a few months, how do you can you share with us a bit, John? How do you measure the performance? I mean, how do you know it's like really working right? I mean, how do you know it's doing what it's supposed to be doing? Can you kind of give us some visual on that, John?
Yeah. I'm gonna show you a partial part of a pie trend, and as I mentioned before, when we run with what we call the process in the machine, this yellow line represents that extraction, and so it's full open, and the white line represents the steam flow to the host. And we're flowing, somewhere in the neighborhood of, 300, a little over 300,000 pounds of steam per boiler into the system. Now, when we cut in this new valve, the letdown valve, at this approximately same 72,000 pounds an hour of steam to the host, we can now really back the unit off. You can take the megawatts down from 49 to say 44 here in this snapshot. And of course, you can also back off the steam flow. So by doing that, we can get back to where we're supposed to be, in our contract at 46 megawatts. We burn less coal. We use less lime slurry, for SO2 control. So there's quite a bit of savings to the plant, when this is going on.
So John, so thank you. And so speaking of savings, again, not to give any kind of trade commercial secrets out there, but like a 30,000 square foot view, can you share with us a ballpark on what the all-in cost was for install and the valve and to make this investment? And could you share with us perhaps a ballpark on the financial payout to the plant on a monthly basis?
Right. So we budgeted and spent about $200K for the valves. We also bought a feed water control valve to better size that as well for the spray on the letdown.
Spray water
and the installation contractor. So those two things together total up about $200K. We've realized savings per month now in the 75 to 100K range. So the project paid for itself pretty quickly, which is unusual, but it's also one of the things we strive for, to get something to pay back within 2 years, and to have it pay back in just a couple of months was huge.
Wow, John. Thank you so much for sharing your success story with us today, John. Thank you. I got to tell you that, I've known you for a bit, and as a hands-on engineer, it's got to be really, feel really good to take something from cradle to grave like that, John. Just
it does.
Yeah,
it does, and I think it's really appreciated by the plant itself, the operations guys, the maintenance guys, and all, because it just makes their life easier. And this valve is actually quite a bit quieter than the old system too. So there's added benefits besides saving money.
That's all right. Cool, John. Congratulations on a successful project.
Thanks.
Thank you very much for joining me on my podcast. Folks, that's going to wrap up today's podcast. Thank you again, John. And for those folks out there viewing this is Bill Wolf signing off. And keep those thumbs up coming. We really appreciate it. And we'll see you next week. Thanks again.